Alright, what's up everyone? Today we're going to do some basic calculations that were taught in elementary school. Here we go. 21 times 13. Wait a second. How do we get two different answers? What's going on? Right, first, let's talk about the numeral system. The numeral system is a writing system of notations to represent numbers. Right? For example, the numeral system that we use in daily life is called the decimal system or base 10 numeral system. For example, in this system, this number here, 873, means 8 times 100, or 10 to the second power, plus 7 times 10, which is 10 to the first power, plus 3, which is 3 times 10 to the 0th power. In computer, we use only zeros and 1 in our digits, which calls the binary system or base 2 system, such as 1011, and we usually would denote it this way, and we will talk about what this means later. 1011 means 1 times 2 to the third power plus 0 times 2 to the second power plus 1 times 2 to the first power plus 1 times 2 to the 0th power. So in general, when we have a base n numeral system, we will see a number that's denoted this way. Let's say it's A, B, C, and we'll put a subscript parentheses n here to represent it is in base n. So what does this expression mean? It means we have A copies of n squared plus B copies of n to the first power plus C copies of n to the 0th power, which is 1, to represent the numbers that we're looking for. In this video, we will suppose that n to be a natural number that's greater than or equal to 2. So, how do we do the operations? How do the operations work, or how do we do the calculations? Well, let's start with addition and subtraction. Addition and subtraction are actually working the same way, or almost the same as in decimal, except instead of adding 1 into the next digit whenever we reach 10, we now need to add 1 into the next digits when we get n, based on what n is. For example, if we're doing in base 7, where n is equal to 7, let's get the addition table. Well, 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 2 is 2, so on and so forth. And then 1 plus 0 is 1, 1 plus 2 is 2, 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, then 5, 6. But 1 plus 6 is 7, which hits the number of the base, 7 right here. So now we're moving it into the next digits, 1, 0. Okay, so we get the following. Pretty cool, huh? So let's look at the other operation. For multiplication, however, the multiplication table that we used to know no longer works. We need to build our multiplication table with the base n that we're working on. For example, 4 times 4 equals 16, in decimal system. However, in base 5, 4 times 4 has the representation 3, 1 instead of 16. Because the notation are changed, the multiplication table that we used to in common does not apply anymore. So, for example, we're using base 7 again. This time, we'll figure out the multiplication table for base 7. So 0 times 0 is 0, 0 times 1 is still 0, and 0 times any number is still 0. Excellent. Now, 1 times any number is still the number itself. Okay, this is not addition, this is multiplication. So we get 1 times 0 is 0, 1 times 1 is 1, 1 times 2 is 2, so on and so forth. Now, let's say we're doing 2. 2 times 0 is still 0, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6. So far, so good. Now, what about 2 times 4? Well, regularly we say 2 times 4 is 8. But wait, 8 is bigger than 7 already. So we already reached 7. So how can we rewrite it in base 7? Well, again, in base 7, if we have the notation in this form, it means we're going to have a times n to the first power plus b times n to the 0th power, which is 1. So to figure out what a and b should be, we can do a division. And since we're in base 7, we're going to divide by 7. So 8 divided by 7, well, the biggest number we can fill in is 1. Okay, and 1 times 7 is 7, which means after the subtraction, we have 1 as our remainder. This means that now we know the last digit is 1. Next, let's figure out the second of the last digit. Well, we now have 1, and again, 1 is already less than 7, but we can just do the same game again. 1 divided by 7, the biggest number we can put is 0, and 0 times 7 is still 0, so if we subtract it, we get 1. So this 1 is in fact the remainder, meaning that this means this is the number that we need to put in the second of the last digit. So we get 2 times 4 has the notation 1, 1. Right? So if we continue, we will get the rest. Like, so we just saw the examples of how we fill in our addition and multiplication tables. Let's go back to the beginning and figure out what base this belongs to. Okay. Well, notice that in the 3 numbers that we have, in these expressions, the largest digits we see is 3. Here, here, and here. What does that mean? It means that if our base is an integer, then the base must be at least 4. It has to be 4 or bigger. Why is that the case? Well, if we suppose the base is 3 or less, then according to our notations, the digits 3 cannot appear. In other words, we will not be able to put 3 in our notation. Therefore, let's start with n equals 4, and we're going to check out which base this belongs to. Okay, since the addition table is working similar to the normal that we usually do, let's just focus on the multiplication table. And this time, I'll ignore the 0 because we know that 0 times any digit is 0. But I'll leave the 1 here so that we will still able to understand the calculation. So again, 1 times any number is that number itself. So we have 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3. Next, 2 times 1 is still 2. 2 times 2 is, again, we're in base 4. 2 times 2 is 4. But since we're in base 4, we need to add 1 to the next digit and turn the original digits to be 0. So we get the expression 1, 0. Next, 2 times 3 is 6. Again, if we write it in base 4, its notation becomes 1, 2. 3 times 1 is 3. 3 times 2 is 6, which is 1, 2. And last, 3 times 3 is 9. And again, in base 4, we write it as 2, 1. Last, let's try to see how we check this. Well, we'll just do the vertical multiplication as usual. Let's start with, doesn't matter. Let's start from left to right. My personal habit. So 1 times 1 is 1. 1 times 2 is still 2. Very good. Next, 3 times 1 is still 3. There's no problem. And 3 times 2 is, from this table, we said 3 times 2 is 1, 2. And again, don't say 12 because this number is not equal to 12. 3 times 2 is still 6, except our notation looks like 12 only. Anyway, let's add them together. Well, this is empty, so we just treat it as 0. 0 plus 3 is 3. 1 plus 2 is still 3. 2 plus 1 is also 3. Okay, so we see that it's the same as this answer here. For this calculation here, we just figure out that this belongs to base 4. Okay. Alright, for the next video, we'll continue working on numeral system and we'll introduce how to do the divisions. And of course, we'll see more problems so that we'll get used to dealing with different bases. Okay? Pretty cool, huh? So that's it for this video. If any thoughts, please leave your comment below. And if you enjoyed this video, please don't forget to like and subscribe so that you will not miss any of my video. Thank you for watching.